We are now ready to test a claim about a population standard deviation. In this example, we take a sample of 23 participants from an athletic competition, and we are told it yielded the following results about their pulse rates. The mean was 73 beats per minute, and the standard deviation from our sample was 4.6 beats per minute. So let's just kind of write that stuff down. We know that our sample size in this example is 23. We know our sample mean was 73. And the sample standard deviation S was 4.6. Okay. We are interested in whether the following claim is supported. The standard deviation pulse rates for athletes in this competition is equal to 5.5 beats per minute. So this is the claim, that the standard deviation is equal to a particular value. Just like with any hypothesis test, we need a null and an alternative. It looks like the value in question here is 5.5 beats per minute. So if we want to know whether or not the standard deviation is equal to, and that's the claim, well, it turns out we know with the null hypothesis that this is going to always be where the equal to is. So our null hypothesis is that the population standard deviation is equal to 5.5. It always has the equal to, and it turns out this is where our claim is. So this is the original claim. The original claim is actually in the null hypothesis. We want to test that against an alternative hypothesis. And it's not saying here that we want to know if it's greater than or less than. We just want to know if it's equal to. So let's test this against the alternative that it's not equal to. So this is it. This is our null. This is our alternative, just like we would set up any other problem. Now we're going to use StatCrunch to calculate a p-value, but we need to know what are we going to be comparing the p-value to. Well, our level of significance is equal to 0.01. So our level of significance is equal to 0.01. Now when we use StatCrunch, we have to be careful. It turns out StatCrunch actually won't allow you to put in the population standard deviation. What they want you to do is to put in the population variance. So what we're going to do, even before we go to StatCrunch, is convert this hypothesis test into an hypothesis test for variance. So in this case, we can do that quite easily just by taking 5.5 and squaring it. Because we know the standard deviation, if you square the standard deviation, you get the variance. So here, what we're actually going to test is that the population variance is equal to 30.25. versus the population variance is not equal to 30.25. Same thing with our standard deviation from our sample. What we also need to do is to calculate the sample variance. So I need to square 4.6. So 4.6 times 4.6, our sample variance was 21.16. So I'm going to use these values instead of the standard deviation. So let's go to StatCrunch, and we're going to plug these in. And we're going to have to come back to this because my memory is terrible. So we're going to go to Stat, Variance Stats, One Sample with Summary. Our sample variance was 21.16. I wouldn't know that, but it's still in my calculator. Our sample size was 23. So our sample size was 23. And we are testing this against the claim of the variance. The variance is equal to 30.25 and not equal to 30.25. So let's plug that in. 30.25 and not equal to 30.25. And we're ready to go. It looks like our p-value is 0.31. So that is the p-value. Let's write that down. Our p-value is equal to 0.31. Let's double check. 0.31. So what is our conclusion going to be? Well, it looks like our p-value is larger than our level of significance. So our p-value is larger than the level of significance, the alpha level. So what does this mean? We're going to fail to reject. We're not going to reject the null. There is not evidence to support the rejection of the null hypothesis. In other words, we can say there's not enough evidence to reject the claim. So what about it looks like this claim here? Well, we wouldn't say there's evidence to support it. We just would say there's no evidence to deny it, pretty much. You can never prove something is true. You can show that there's evidence that it's not true. And in this case, we are interested in whether or not this is supported. We would say there's no evidence to reject this claim. Versus the alternative that it's not equal to 5.5, we cannot reject the claim that the population standard deviation is equal to 5.5.